for the first set of problems we're going to look at here, directions ask us to determine if each graph is continuous or discontinuous, obviously meaning not continuous, at x equals c. So we're looking just at one specific value. If it is discontinuous, why? So this is the important part. If it's not continuous, we have to explain why. And in our explanation, all we need to do is explain why one of these three things isn't true. Right? In order to be continuous, f of c has to be defined, the limit as x approaches c of f of x has to exist, and the limit as x approaches c of f of x equals f of c. All three of those have to be true in order for it to be continuous. So we can kind of go down the line, check to see if each thing is true. When we find something that's not true, that's our explanation as to why it's not discontinuous. I'm sorry, why it's not continuous. So for this first one, first thing we had in our list is f of c is defined. So if we put c in, do we get something out? Well, in this case, no. We have a hole there. There's no point anywhere when x is c. So this is discontinuous. And the reason is f of c does not exist. And I know some of you out there are asking, can I just say there's a hole? No. I want you to get in the habit of being a little more specific and elaborate when you're writing things, be a little bit more mathematical, because in the AP test, for your response, you need to kind of get used to explaining yourself and doing a better job of explaining yourself mathematically. So here, it's discontinuous because f of c does not exist. We don't have to continue on with those three conditions. As long as one of them is not met, that means it's not continuous. So let's look at number 2. For this one, is f of c defined? Yeah, if we put c in, we have this point right here. So the first part up here, that's checked. F of c is defined. Next thing, the limit as x approaches c of f of x exists. So let's look. As we get closer and closer to c from the left, we're approaching a y value. I don't know what it is right now, but it's right here, this value. And as we approach from the right, it's approaching the same value. So the limit exists. We're approaching the same y value from both sides. So that second condition is met. Now, the question is, does the third condition get met? Well, for this to be true, then f of c has to be the same as the limit. Well, if we look, our limit is way up here, this y value, whatever that may be. Our f of c is this y value right here. Those two things are not the same. So this one is also discontinuous, but for a different reason. This one's discontinuous because the limit as x approaches c of f of x does not equal f of c. Right? The limit is not the same as the actual value. So this is not continuous, and we can see it. It's pretty easy to see it, but this is the reason why it's discontinuous. All right, what I'd like you guys to do now is, before you watch the next videos, try 3, 4, 5, and 6 on your own. Again, remember, when you're explaining why it's discontinuous, you need to look at these 3 reasons and use one of these 3 reasons to explain why it's discontinuous. So go ahead and try those last 4 on your own.